evening. It's great to see you. Welcome to the new Oberlin debate series, and I want to acknowledge our former trustee, Steve Shapiro, sporting a beard now, who has been one of the inspirations behind this. Since the college was founded in 1833, Oberlinians have been at the forefront of dialogue on topics that have shaped the history of our country and our world. The debate series was created in honor of this tradition and to give our students, faculty, staff, and community an opportunity to be informed and to participate in these important conversations. Tonight's debate topic is the state of the climate. This topic was chosen because it speaks to Oberlin's commitment to environmentalism, sustainability, and combating climate change. We are fortunate to have two prominent climate experts as our debaters this evening. They are Patrick J. Michaels and Judith Curry. Their debate and discussion will be moderated by Steve Weidel, who is our Associate Dean for Curriculum and Professor of Geology in our College of Arts and Sciences.
Thank you, Steve.
Patrick J. Michaels, to my far left, is the Director of the Center for the Study of Science at the Cato Institute. He has 30 years of experience as a research professor with degrees in biological sciences and ecological climatology. He is past president of the American Association of State Climatologists. He was a contributing author and is a reviewer for the United Nations Intergovernmental Panel on Climate Change. That panel was awarded the Nobel Peace Prize in 2007. Dr. Michaels has written or edited 6 books on climate and its impact. His writing has been published in Climate Research, Climatic Change, Journal of Climate, Nature and Science, among others. Dr. Judith Curry, to my immediate left, is professor and former chair of the School of Earth and Atmospheric Sciences at the Georgia Institute of Technology. She researches climate dynamics of the Arctic, climate dynamics of extreme weather events, and reasoning about climate uncertainty. She is a fellow of the American Meteorological Society, the American Association for the Advancement of Science, and the American Geophysical Union. She serves as president and co-owner of Climate Forecast Applications Network, or CFAN, C-F-A-N. CFAN translates the scientific weather and climate research so that governments and industries can better anticipate and manage weather and climate-related risks. There will be an opportunity for questions from the audience that Dr. Weidel will moderate. Ladies and gentlemen, without further ado, please welcome Dr. Weidel, Dr. Michaels, and Dr. Curry.
Thank you very much, President Krislov. I have only a few things to add by way of introducing our two speakers this evening. Judith Curry, as you mentioned, has been, in fact, actually a prolific author on climate. You can see here a paper taken from Nature Geoscience. It was published in February of this year. She also has recently had a relatively vital life on the internet, and we can see likewise that Dr. Michaels also has had, in fact, actually a significant set of publications. This one taken from the American Geophysical Union Science Policy Conference, and he likewise has an active life in the blogosphere. What we're going to have them talk about tonight, of course, is the state of the climate. And what we'd like to try to do is to have them start by talking a little bit about the so-called instrument record and seeing where they can go from there. And I will ask Dr. Curry if she would like to take the podium first. Yes, this is you.
I'd like to thank you for inviting me to this event, and I'd like to commend your president and your institution for hosting this debate series, which I think is a wonderful idea. Okay, so what do climate scientists agree on? Well, everyone agrees that surface temperatures have increased since 1880. Humans are adding carbon dioxide to the atmosphere. Carbon dioxide and other greenhouse gases have a warming effect on the planet. The disagreement is on the more substantive issues. Whether the warming since 1950 has been dominated by human causes. How much the planet will warm in the 21st century. and whether warming is dangerous, and whether we can afford to radically reduce CO2 emissions, and whether reduction will improve the climate. The items listed in black relate to science, whereas the items in blue refer to values, policy, and politics. I'm going to open my remarks with some comments about these two issues. Okay, here's a graph of the global surface temperature anomaly since 1850. Okay, we see this warming period from 1910 to about 1940, then a slight cooling until the late 1970s, and then a sharp warming until the end of the 20th century, with a relatively flat period in recent decades. Now, the UN Intergovernmental Panel on Climate Change, in their recent assessment report, they concluded that it's extremely likely that more than half of the observed increase in global average surface temperature from 1951 to 2010 was caused by humans. The best estimate of human-induced contribution is similar to the observing warming over this period. You can't, just from looking at this figure, you can't tell what's causing the warming. Okay, so how do scientists make this inference that most of it is human caused? Well, they use climate models. Global climate models are used to compare simulations with only natural forcing, on the top diagram, with simulations that include both natural and human-caused forcing, and then compare with observations, which is in the black curve. You can see that the simulations with both human and natural forcing are much closer to observations after 1970. However, climate models do not capture the large warming from 1910 to 1940. See, it's pretty flat. The cooling from 1940 to the late 1970s, and the flat temperature in the 21st century. Okay. Not advancing. All right. So, can we have confidence in what the climate models are telling us? Well, it would be, the key question is, how much of this really could be explained by natural variability? So ideally, we would be able to look back a lot farther into the past than 1850 to understand what natural variability was. How many people have heard of the hockey stick climate? Okay, about half of you. Well, this is from the third assessment report from the IPCC in 2001. And this is determined from what we call paleoclimate proxies, tree rings, for example, ice core. And we see that in the third assessment report, things were pretty flat, slightly declining, and then boom, right in the 20th century, we saw this big increase. The more recent assessment shows that it's not quite so simple, that there's a lot of disagreement among the different reconstructions. And here we see the medieval warm period, and the big question is whether the temperatures about 1,000 years ago were as warm or warmer than the current temperatures, and this is still a subject to debate. The other issue is the paleoclimate proxies are far from perfect measurements of temperature. There is one historical record that goes back to 1650, and this is the Central England temperature record. And what you see is enormous variations year to year and decadal, and you see this particular big negative spike and then upward increase around 1740. And so you see some sense of a warming trend, but you see this is really dominated by year-to-year variability. And so trying to understand all this natural variability and all the regional variability is very challenging indeed. I'd like to draw attention to the recent period, the last 20 years, where there's been a pause or hiatus in the warming. If you recall, when I showed the climate model simulations, we saw the climate model and the observations diverging. So basically, we had a big El Nino in 1998, and since then, the temperature has been pretty flat. He says, well, why does this matter? Well, the fourth assessment report in 2007 said that surface temperature is expected to increase by 0.2 of a degree centigrade per decade in the early 21st century. Instead, it's been flat. This projected warming clearly has not been realized. So what's going on? Well, the significance of the pause since 1998 is illustrated in this figure. The spaghetti diagram shows a number of different climate model simulations of future warming. And you see that the climate models predict relentless warming. There's lots of year-to-year variability and wiggles, but there's a relentless warming trend. Or here we see the observations, and that the observations are really have fallen slightly below even the coolest models. And so since 1998, which has been the period where we've seen 25% of the total human impact in terms of CO2 emissions, we've seen under conditions of human-caused greenhouse forcing that model pauses longer than 15 years are rare, and the probability of a model pause exceeding 20 years is vanishingly small. So there are some serious questions raised by the discrepancies between models and observations. Are climate models too sensitive to greenhouse forcing? Is climate model treatment of natural climate variability inadequate? Are climate model projections of 21st century warming too high? Well, what does all this mean for future warming? Well, here's the projections from the climate models, and what the IPCC did is that they lowered the warming projection to account for the apparent oversensitivity of the models, even dropping below, on the lower bound, below what the climate models project. And they say that the pause will end soon with the next El Nino. And so if you project even farther into the future, okay, what will happen in terms of the future climate? The IPCC argues that it depends on how much greenhouse gases we emit. If we start drastically reducing greenhouse gas emissions, we can stabilize. If we're on a business as usual trajectory, we're somewhere up here. However, do we have confidence in these climate models after we've seen that they're not doing a very good job at all in the early decades of the 21st century? The climate models are oversensitive to carbon dioxide. They don't predict the correct phasing of the multi-decadal internal variability, the long-term oscillations in ocean circulation, and they don't predict solar or volcanic activity. Okay, so what are we to make of all this? How much confidence can we have that most of the warming has been caused by humans and that we can expect substantial warming in the 21st century? I think there's a whole lot that we don't know about the climate system at this point, and that we're facing conditions of deep uncertainty in terms of the future projections of climate change.
Thank you for having me. President Krisloff, I'd like to specifically thank you. It is not an easy task to invite speakers that may be unpopular or controversial. I don't know why that's applied here, of course. I'm sure what happened is you received comments such as, well, what are you going to do next? Invite them to debate gravity? Well, actually, the issue is something much more subtle than that. It is an issue of extreme subtlety. And the next correct debate, if it were about gravity, would be about the interaction between gravity and the Big Bang. It would be a very enlightening discussion, and that's what I hope we have. So, global warming science and policy. There is a strange disconnect that Judy alluded to in her conclusions. By the way, I'm the director for the Center for the Study of Science. we're going beyond global warming. The global warming issue to me has revealed that there are certain issues with regard to the incentive structure in science that may be creating distortions, not just across climate science, but across much of other science. Let's start off with the same picture Judy showed. This is the temperature record from the University of East Anglia. It is the one that scientists believe the most because of the way that missing data is treated and other things. The record that you see in the media the most is from the NASA Goddard Institute for Space Studies, and it does things to Arctic temperatures that are beyond the rules of Physics 101 and should never be permitted. Well, now, there are two warmings in the 20th century. There's the first one, 1910 to 1940, and then there's 1976 through 1997, 1998 rather. And to disagree with the previous speaker a little bit, they are statistically indistinguishable from each other. The trends are not distinguishable under normal statistical analyses. So if you want to know what caused this one, the three most important words in life, there are three sets of three most important words. I love you, we were wrong, and I don't know. And the answer to this one is, I don't know. Now, the warming of the second portion of the 20th century is very interesting because people say it has to do with changes in the greenhouse effect. And you know what? I agree. And I'll tell you why. I'll tell you a little bit about the greenhouse effect. Molecules that are shaped like this absorb infrared radiation coming from the surface of the Earth. And that radiation would normally go out to space. But because they absorb it, they then re-release it. And it can go back up, out to space, where it would have gone anyway, or it can go back down. 50-50 chance. So what happens is the lower portions of the atmosphere warm, but the stratosphere above 50,000 feet in the tropics cools. And guess what? Take a look here. These are stratospheric temperatures measured by satellites beginning that went up at the end of 1978. Notice that they're going down. And also notice something very strange happened around 1994. They stopped going down. How can you be continually increasing the infrared absorption of the lower atmosphere by dumping carbon dioxide into it and have the stratosphere stop warming? Three words. I don't know, nor does science. But, obviously, the climate change deniers suggest there's still a debate over the science. Well, there's quite a bit of subtlety in this. The word denier is not a scientific term. It's a political term. If there were speech codes, which there are in some universities, I would say this word would be one that you might want to think about, but I don't support speech codes, obviously. Here are the facts. Here's the subtlety on climate change. You know, you learn as a kid, you live in Ohio, it's not the heat, it's the humidity. No, it's not the heat, it's the sensitivity. Global warming will occur, and has occurred, because of putting carbon dioxide in the atmosphere. It's done it in the past, it'll do it again. The question is not that, it's how much it's going to warm. Well, here's, the sensitivity has a definition. It's the amount of warming you get, ultimately, for doubling the atmospheric concentration of carbon dioxide. And here are the calculations that went into the penultimate United Nations climate report. You'll see, whoa, you will see, for example, a peak warming predicted by this green model somewhere around sensitivity of around 2. They all have these very long tails. So there's a high, not a vanishingly small probability that we could have a very large warming. And that's what is running policy from a scientific point of view. Well, beginning in 2011, something very interesting began to happen. Science began to correct. You haven't heard about this. You don't read about this. Beginning in 2011, experiments started to appear in the scientific literature showing much lower sensitivities to carbon dioxide, much lower sensitivities to a doubling. On the top here is the IPCC's climate model range on 90% confidence. Here is the assessments range. This is that low end, Judy said, they just added on. And here's all this science that has come out since 2011. Wow, that's amazing. You know what? This is all the papers that I found on it. Some people say there are some more. There was one that was published in 2002. And if you read about this paper, you will see that this is where ClimateGate participants decided to try and fire the editor that allowed this to be published. Not only just from his journal position, but from his position as the associate provost at Auckland University, which is the Harvard of Australasia. It's nasty out there. I want to talk to you a little bit about what's really going on with the climate. Here's a good one. This is Arctic sea ice extent, as measured from microwave sounding satellites beginning in 1979, and it's going down. Now, what you don't know is when the satellite was launched, actually in late 1978, do you know why it was launched? Do you know what the excuse for the funding was? The Arctic ice is growing. It's really cold in the Arctic. It was launched at the end of the coldest period in the Arctic since the mid-1920s. So it started above its long-term mean. This is the 0 for the entire record, by the way, and then it drops here rather precipitously. Now, what you haven't been told is the drop stopped about 7 or 8 years ago. The noise is greater within the year in terms of departure from normal because the ice is thinner, but that's not actually going on anymore. Now, this is a globe. The last I heard, a globe has 2 hemispheres. So let's take a look at the ice extent measured by satellite, an objective measure, in the southern hemisphere. And yes, that is a statistically significant increase. The net is actually slightly positive right now over the entire record. Amazing how some people get away with only thinking the Earth has 1 hemisphere. Now, hurricanes are getting stronger, right? Everybody knows that. Basic science. A hurricane is a heat engine driven by the surface temperature of the ocean and the upper layer temperature of the ocean. So if it warms up, the hurricane becomes stronger. So we can measure the strength of hurricanes around the planet. There's a guy by the name of Ryan Maui, who I've been working with quite a bit, from Florida State University. He's very, very, very quick. And what Maui did is he did a logical thing. He examined satellite records. The satellite coverage goes global in 1970. With a satellite, you can see every hurricane. You can't see everyone with just relying on ship reports or airplane reports. Some of them are in very remote places. And you can tell the wind speed in a hurricane by the way the hurricane looks on satellite. So, you take a look at the wind speed, you take a look at how long it's at that wind speed. Speed times time is energy, okay? And so let's take a look at what's called the accumulated cyclone energy index around the planet. This is supposed to be getting stronger. Record begins in 1970. There's no relationship with the surface temperature whatsoever. The top is global, the bottom is the northern hemisphere, and in between is the southern hemisphere. Now that's a strong prediction that was made by some people. That's just not happening, and it's a very, very important prediction. Oh yeah, then there's this. This is a slight problem right here. It is that. You see, the statement that the United Nations made, that the pause will stop with the next El Nino, is wrong. At least it's not, or it will stop as soon as there's another El Nino. You know why? We're having an El Nino right now. And I can tell you this, if it warms up at the rate it was warming up in the late 20th century, this trend will not be significant until it's 25 years old. But that's not going to happen tomorrow. And here is the end of my discussion for the first part. This is what I call the thermonuclear slide. The United Nations has 105 climate models. The average warming trend predicted by these models is given by the black dots for the last 10 years, the last 11 years, the last 12 years, all the way back to the last 62 years. This is back to 1951 to now. The last one is 2004 through 2013. These are the confidence limits for 95% confidence limits. You got a sample size of 105. It's got a mean, it's got a standard deviation, and you can do parametric statistics on it. This is the 97.5% confidence limit. It'll be done in 30 seconds. The colored dots are the observed temperature trends from that same temperature history that scientists rely upon. Notice one thing. Every observed temperature trend of any period in length is below the average predicted by the models. Where the dots are green, they're within the statistical variation of the models. They're within the 95% confidence limits. Where the dots go yellow, they're outside of the 95% confidence limits. And when they go red, they're outside of the 97.5% confidence limits. This is what happens when you make these models have to reproduce the last 65 years. They don't work. Now, normal science, when a hypothesis fails at the 0.05 level, you readjust the hypothesis. We haven't done that as a community. And my forecast, my end for this discussion is, the longer we wait, the more months we wait, the more years we wait to say those 3 words, we were wrong, the bigger the damage is going to be. And it's not just going to be to climate science, it's going to be to all of science. What would you think of a society that no longer trusted science as a guideline for policy? We could be headed in that direction unless we say it. We were wrong. Thank you.
Okay, I want to use my next segment to talk about, okay, now what do we do? How should we respond to the challenge of climate change in light of the uncertainties? Well, the precautionary principle. How many of you have heard of the precautionary principle? Okay, about half. And it states that where there are threats of serious or irreversible damage, lack of full scientific certainty shall not be used as a reason for postponing cost-effective measures to prevent environmental degradation. So based on the precautionary principle, the UN Framework Convention on Climate Change established a goal of stabilization of atmospheric greenhouse gases to prevent dangerous climate change. And this is regarded, the dangerous climate change level is 2 degrees centigrade relative to pre-industrial period. We've already had about 0.8 of a degree warming. We have 1.2 degrees to go. It's a rather arbitrary limit, okay, but this is what was set as the dangerous level. Okay, so we have a key climate policy dilemma. Whether betting big today with a comprehensive global climate policy targeted at stabilization will fundamentally reshape our common future on a global scale to our advantage, or quickly produce losses that throw mankind into economic, social, and environmental bankruptcy. The key issue with the precautionary principle is the cure worse than the disease? So we're faced with conditions of deep uncertainty with regards to the climate problem. In the decision-making world, that there's 3 criterion for deep uncertainty. Situations in which phenomena are characterized by high levels of ignorance and are poorly understood scientifically. Modeling and subjective judgments must substitute extensively for estimates based on experience with actual events and outcomes. And ethical rules must be formulated to substitute for risk-based decisions. So there's a number of options when faced with deep uncertainty. The way the climate policy debate is portrayed, it's a debate between the precautionary principle versus delay and do nothing, delay, gather more information. Well, there's a number of different strategies, and I highlight the ones in red because these are ones that are growing in traction. Enlarge the knowledge base for decisions, adaptive management, and build a resilient society. Robust decision-making. Robustness is a strategy that seeks to reduce the range of possible scenarios over which the strategy performs poorly. It uses available information to distinguish reasonable from unreasonable choices, and it's flexible and can be adjusted quickly to increase the information. Now, at the heart of the debate is really a conflict of values. The UN is really working under the sustainable set of values. We're looking to maintain our resources, mitigate damage. The policies are associated with sacrifice, austerity, and obligations. The sustainability values are in direct conflict with survival issues in the developing world. Okay, there's a whole a very substantial portion of the world's population. When you say clean green energy, they mean anything other than burning dung in their dwelling to cook food and for heating, okay? They're looking about personal survival for their group and for nation, and it's really about meeting basic needs. The other value is resilience, and this is about bouncing back, recovering quickly from difficult conditions, survive longer in a changing world. It's really adaptation. Funds for carbon dioxide mitigation directly compete with funds for adaptation. So these two strategies are directly competing. And then we have another set of values, which I put under thrivability. People want to make money. They want to prosper, thrive, develop vigorously, strive for greatness. Concepts of anti-fragility. So you see there's a conflict of values and different policies that tie in with these different value systems. And how can we make progress? Well, if you can come up with robust policies that speak to values in more than one of those columns, then you have something that could work and is politically viable. For example, if you look at the intersection of what makes sense with the sustainable values and the resilient values, we have some strategies like water resource management, ecological conservation and restoration, energy research, etc. And another example, if you look at trying to deal with survivability issues and come up with some policies that make sense, well, maybe combining the needs of survivability with some of the strategies from thrivability, where you have anti-fragility, you can learn and grow from volatility and unexpected events. Strategies include economic development, reduce the downside from volatility, look at small local experiments, tinker, and try to generate transformative ideas. So the point is that we're operating in conditions of deep uncertainty. Climate change is genuinely a wicked problem with the scope of the problem even poorly defined and ever-changing and ever-growing. Solutions all have unintended consequences. So there's no silver bullet solutions. But by recognizing that there's a lot of different values at play here and trying to come up with robust strategies and looking at some of the concepts from anti-fragility, I think we can make some progress on this issue.
When we were chatting so amiably, I did not want to reveal my next slide, which will say this. So, let's do even more than the cap and trade bill passed by the House of Representatives in 2009 did. That would reduce our emissions of carbon dioxide by 83%, 36 years from today. Be impossible, but let's do even more than the impossible. Let's reduce our emissions 100%. Now, the United States, and we're going to show leadership, because the president was just at the UN, where he said, we will show leadership, but you must do your part. So, how much global warming will our leadership save? Well, we could consult the Environmental Protection Agency. The Environmental Protection Agency has its own model that assesses the impact of various policies. It assumes a sensitivity of 3 degrees Celsius, which I just showed you is too high. Say United States, reduce emissions to 0 right now, and it will calculate the temperature. It is called the Model for the Assessment of Greenhouse Gas-Induced Climate Change. And if you're paying attention, you will realize that the acronym for that is MAGIC. I am not making this up. They call it the MAGIC model. And so what you see is if we do nothing, business as usual, 2.62 degrees warmer in 2100 than it is in 2005. And if we reduce our emissions to 0, this is the amount of warming that we prevent. 14/100ths of a degree. So you wouldn't even see it. Well, people are catching on. This is from Garth Paltridge, who wrote in Quadrant this year that people, the chap in the street is beginning to recognize that oversold environmental campaign from miles away and beginning to suspect that it is politics rather than science, which is the issue, therefore the next image. Now, the U.S. is responsible for 14% of global carbon dioxide emissions. That magic calculation that I showed you kept us at 14%. But in fact, we're going to be less because other nations are going to grow. But he went to the United Nations to commit the United States to these completely futile emissions. So I just thought I'd show you what heads of state did not show up at the United Nations a week ago Tuesday. That would be Xi from China, the Prime Minister of India, Harper from Canada, Angela Merkel from Green Germany said she had something better to do, and Prime Minister Tony Abbott from Australia. Together they are responsible for 38% of global carbon dioxide emissions in the year 2012, which is the one for which we have the latest data. So, the folks who do all the admitting, they don't seem to want to play ball. So, I'm going to close here with something very interesting. I have begun to look at science in general. There's a guy by the name of Daniele Finelli, who is at the University of Montreal, and he wrote a paper in 2012 that was mind-boggling. Here is the title of the paper. Negative results are disappearing from most disciplines and countries. That's right. Over the last 20 years, science articles reporting support for the stated hypothesis have gone up by 20%. Ladies and gentlemen, that's impossible. We are not getting smarter. What's happening is science is solving non-problems because solutions to non-problems that generate positive results make sure that the funding agency keeps you funded. Negative results don't help. And you should care about this because it's not just global warming. You know, our regulatory state claims a basis in, quote, science. Scientists say, I could be Al Gore, scientists say, we are all going to die. And when I put my hands on my chest like this, I'm lying, or at least exaggerating. Anyway, regulatory agencies rely on what we call summary science, summaries of the extant scientific literature. So if the science is increasingly unreliable, we may be regulating against non-existent or exaggerated threats. This is not a conspiracy. It's merely incentives at work, okay? Nobody's agreeing to lie. And so, when we summarize climate science in the United Nations report, and the summary is done accurately as to what the large body of existing science is, guess what? The number of positive results is going up like this. The number of confirmatory results with regard to climate models is going up like this. Even as the temperature forecast in the models does this, and the reality we live in does that. That's kind of remarkable. That's a recipe for very bad policy. And I'd like to say I'm the only one that's noticed this. But in December, Randy Schekman got the Nobel Prize in Physiology or Medicine. That is not a typo, that's what it's called. The 2013 Nobel Prize. And he wrote an op-ed that was published in the London Guardian. London Guardian is pretty far to the left, okay? And the title was How Journals Like Nature, Cell, and Science Are Damaging Science. What did he say? What he said was that what the journals are doing is they're publishing stuff that will get on television. And that's ignoring a lot of worker bee, very important science. Now what does that do? Where do scientists go? What happens if you publish in Nature or Science? Well, it guarantees academic tenure, raises the likelihood of substantial federal awards, and more important to any academic, it will keep you out of coach, okay? Because you're going to be flying around enough. Scientists therefore gravitate toward research topics and results that will be published there. Well, there's a great opportunity cost then for the rest of science. And unfortunately, the need to keep the results stream positive creates a literature that, under no conspiratorial framework whatsoever is not, in fact, representing reality, because positive results are increasing at an impossible rate. Like I said, when I closed my first section, we have a problem, because when this thing blows up, it's going to blow up a lot more than just climate science. Thank you.
And those of you who have questions, if you will come down to one of the two microphones, and I'd be happy to entertain any questions. Please state your name, if you would.
Hi there, my name is Dave Simon. I have a question about the specific implementation of the concept of anti-fragility in policy and science. This is a term and concept that was explored probably by Nissan Taleb. And how would you recommend implementing this idea specifically? And also, at what point will it become a landscape of knowledge and policy such that the realm of seeking anti-fragility is less relevant?
Okay, well, I'm probably the first person to throw out this idea of trying to apply the ideas of anti-fragility to climate change policy and really to adaptation. It's this whole idea of bouncing forward as we, rethink. It has to do with trying to minimize your downside, which means being very well prepared, having advance notice, having, some of the things for resilience and adaptation, but it's also really a looking forward, reimagining the infrastructure of the 21st century to be, genuinely different, to, have these challenges provide impetus for us to bounce forward and really do something bold and new.
May I take a crack at the question, seeing as this is a debate? I don't think we need to implement it, because we do implement it. We implement it because we respond to bad things that happen to us. Example, in the mid-1990s, there was a horrendous heat wave in Chicago. It occurred on a weekend. The heat index in southern Wisconsin, in rural southern Wisconsin, I think hit 139. That's Death Valley-like. And there were between 700 and 800 excess deaths that weekend in Chicago. 3 years later, there was another heat wave of similar proportion, maybe not quite as bad, and many fewer people than you would have expected died. What happened? Anti-fragility, adaptation. The political process came into action. The mayor of Chicago was pilloried for not having enough services to even remove the bodies in the heat of July in Chicago. And so people adapted. Here's another example, quickly close. Our cities are getting warmer. We don't need climate change to make them warmer. The bricks, the buildings, and the pavement retain heat at night. They impede the flow of wind. Cities tend to be, major cities, about 2 degrees C warmer than the surrounding countryside. In Washington, D.C., the heat island is even bigger than that. It's one of the biggest known ones, probably the waste heat from all the money changing hands, and bodies bumping into each other in odd combinations. But the fact of the matter is that these cities are performing an experiment for us in adaptation. And so what happens as heat waves become more frequent, as they must, because of the urban heat island effect, and as they will, because global warming is going to resume, might be pokey, but it's going to resume, and that's going to be an overlay on that. The amount of heat-related mortality goes down as heat waves become more frequent. In every American city, heat wave mortality has gone down, except one. That's Seattle, where it's not very hot ever. Heat wave mortality in Tampa and Phoenix, two of the cities with the oldest age distributions in the country. Guys, I don't think you go looking for young wives in Tampa or Phoenix. They don't even have statistical heat-related mortality. That's anti-fragility. It's human behavior.
No, it's one comment. Adaptation is bouncing back. I think that's what we're talking. The anti-fragility is bouncing forward. So there is a subtle difference between adaptation and the anti-fragility.
Okay.
Appreciate that.
Next question?
Dr. Michaels, Dr. Curry, thank you both for being here. I'm glad that we agree that the Earth has gotten hotter since 1850, and that's where my agreement with you guys stops, but I won't argue anything past that from this microphone stand. But one thing that I think is really important is that we recognize the growing number of people on the political right in this country. I'm thinking particularly of Secretary of State George Shultz and Hank Paulson, who have stepped forward in recent years as advocates of climate change mitigation policy and said, look, this is happening, it's happening now, and no matter what's causing it, we need to be ready. That's really important, but at the same time, the good people over at the Pew Foundation tell us that only 33% of Americans do not believe that the Earth has gotten hotter since 1850. So that's 1/3. The rest, the other 67%, believe it's gotten hotter and are conflicted as to why that's happening, as are, I guess, you and I are in conflict about that too. But looking at that 33%, you're not going to make policy happen, whether you want to do adaptation or mitigation or anything, if 1/3 of Americans don't believe that the Earth is even getting hotter. As scientists, especially you, Dr. Michaels, with a great deal of experience in talking to people on the political right in this country, how do you think scientists and policymakers can do a better job of communicating to this 1/3 of the American public that the Earth has gotten hotter since 1850 and that it at least might continue to get warmer in the immediate and far future?
Well, I believe that's correct. That's a very well-spoken question, and I'm going to take one point of disagreement with you. I think 1/3 who not believing something is, and given the political divisions in this country, that's a relatively small number. What you didn't mention was the other aspect of the Pew poll, which is really amazing, which is that Pew gave its polling sample 20 issues under discussion in the United States. Police care, water quality, global warming. Global warming came in 19th out of 20, and the actual numbers worked out that only 30% saw it as an important concern. So that's where the problem lies. The political process is merely responding to these polls. And I'll give you one more, and I don't want to be too wordy. Let me tell you how responsive the political policy is, responsive it is. In 2009, the House of Representatives passed cap and trade, the emissions reduction bill, on June 26, 2009. On June 29, 2009, Rasmussen's presidential approval index went negative, meaning strongly disapproved, passed strongly approved, and it stayed negative until 1 week before the 2012 election. In other words, stayed negative through the 2010 election. The House changeover was 64 seats from Democrat to Republican. Nearly every close race was lost by a Democrat who voted for cap and trade. In the Senate, nearly every close race was won by a Democrat. The Senate never voted for cap and trade. They both voted for health care. So the political you don't think these guys know that in Washington? Oh my God, it cost us control of the House until the next redistricting, maybe if we're lucky. It would be 2013, January. 2023, January. So there's your problem, is they are gun shy against a wave election more than anything else. If you want to change policy, we're going to have to change minds. Okay?
Dr. Curry, do you have anything that you would like to add to that?
No, I think we spent.
Could I follow up
Sure.
really briefly, Dr. Michaels?
Very
Yeah, it's my follow-up. I had the opportunity to ask my congressman last year what percentage of his colleagues on the Republican side of the aisle were climate change, not skeptics, but deniers, did not believe that the Earth had gotten hotter since 1850. He suggested about 50% of them did not believe that the Earth had gotten hotter since 1850. I don't know anyone with more direct experience in the US House of Representatives than this guy, but I'm wondering how you would suggest at least getting through to these elected officials.
I spend more time trying to correct my so-called friends Honest to God, who say that. I say, please don't say that. You'll get slaughtered in the debate, and I'll do it if you want me to. It boggles my mind, okay? You show an XY plot, Judy shows an XY plot, and there's no response. Can't deal with that. I'm just telling you, I spend more time with them. And by the way, I'm not right-wing, I'm libertarian. I'm sure you know the Cato Institute believes in a lot of things that you all feel pretty strongly about, like sexual equality and decriminalizing some very bad things. The right to
fix the knowledge deficit is pretty much a lost cause. You know, that there's people who don't care, who just aren't going to change their mind no matter what. And so you just have to figure workarounds for it and find other common ground, other strategies for moving forward. But the whole idea that we're going to fix the knowledge deficit problem on this issue is just, it's a lost cause.
Thank you, doctors.
Can we have the next question?
Thank you. Dr. Michaels, early on you said something was, all I have in my notes is beyond rules of physics. And I think it had to do with the difference in temperature, surface temperature and the stratospheric temperature. And you suggested that typically that would be heating up. And I'm not sure if that was the case, but
No. He'll be cooling down.
Right. Okay, right. There should be some kind of balance there is what you're demonstrating. But you know, if that's actually happening, then it shouldn't be against the rules of physics. If it is an error in one, that might explain it, but that, yeah, I don't know.
That's probably a very poor choice of words, and you're a very observant, very observant man. Thank you very much. It was beyond our knowledge of what's going on. How's that?
Okay, not being a physicist, I took issue with that on behalf of physicists.
Physicists around the world, thank you, and so does Judy, right?
Okay, all right.
Thank you. Next question?
So both of you who would be considered making more conservative predictions about climate change have spent a lot of time being asked to participate in interviews in the media, etc. So I have a question about how the media treats the climate debate. So a recent survey of scientists indicated that people who have more conservative climate predictions proportionately to the sort of scientific consensus are interviewed a lot more. And I was wondering if either of you have any opinions about how much responsibility the media has to represent the scientific community proportionately to.
Yeah, I have real strong opinions. You know, I was at a workshop on the ethics of communicating uncertainty. This was about a week ago. It was lawyers, journalists, and a couple of scientists who were talking about this issue. And the journalists in the room most felt that, well, we have an obligation to, portray, the consensus, what the IPCC says. He said, they felt that in the room. He said, but a lot of their colleagues felt that they have no obligation to do that it's important for them to put forward the minority views. And the reason it is very important to put forward the minority views is because they are squeezed out and marginalized by government funding, by the consensus, that the minority perspectives are really disadvantaged, if you will. And so by giving them some time in the media, without that, these perspectives would not get heard. Okay, and mine is a minority perspective. I don't diverge that much from the IPCC, and I probably get more airtime than the average person, but because of the skewed population, and it's a lot easier to make your way in academic circles just to go along with the consensus than it is to buck it. You've got a minority that gets marginalized, and it's important that that minority be heard.
May I ask you a question? Did you mean to say that those who hold, I really don't like using the word conservative because I wouldn't call myself a conservative. Those who hold views that warming has been overestimated,
Yeah.
get interviewed inordinately an inordinately large number of times? Are you really suggesting that?
I'm not saying they're interviewed more than their counterparts. I'm saying in proportion to what percentage of the scientific community they make up.
Okay, because I mean, the LA Times, won't even publish anything that says that those models are wrong. They actually have a policy of that. And NPR, I think I've been on NPR twice in 25 years. Not NPR, the television station that nobody watches, whatever it is.
Thank you. Next question, please.
Hi. So the slide behind you is about incentives, and there are lots of different kinds of incentives, and I'm just wondering if you have thoughts about how sources of funding can potentially affect science or the objectivity of science.
Yeah, it thwarts which problems get worked on. Okay, in the climate research, because of the UN Framework Convention policies and the IPCC, all of the government funding has gone into investigating human-caused climate change. And there hasn't been money spent on investigating solar climate connections and natural climate variability and whatever. So it thwarts what problems actually get worked on. And it also, by being on the treadmill for getting government funding, you're working on problems that they're putting an announcement that they want proposals for. You're not working on what you want to work on. And so now that I've gotten off the government funding treadmill, I feel much more freedom to explore a broader range of scientific topics.
I actually was talking more about how industry funding of science.
What industry funding of science?
Industry, yeah, it's
It is so
none.
good, it's unbelievable. But I have an idea for you that you're going to.
Statistics?
What's that?
Am I-
God! Yeah, I did the calculation when the last number that I saw, it was at least $10,000 to 1, and it's much greater than that right now. Industry hardly funds anything.
Am I
They won't
incorrect?
touch it.
Am
What's
I
that?
incorrect in understanding that the Cato Institute is largely funded by the Koch brothers?
That would be about 95% wrong, seeing as 95% of all our contribs come from individuals. We are the largest in terms of number of individuals per scholar, individuals contributing. We're the people's think tank. But no, I know what you're saying, okay? And I'm gonna help you out by saying something outrageous. I think what we're seeing in science is very, very, very scary. When public funding is by its nature political. A politician doesn't release $1 bajillion for research money to DOE and NASA and the Department of Energy for global warming unless he's going to go out in the stumps and say, see, I saved you from certain doom. Well, fine. That's the way it works. Wouldn't it be cool if we had a cap and trade program for funding in the following sense? Let's just take a number. Let's say 100 million. That's a crazy number. It's way too small. But let's say there was a $100 million pot for research on climate change. And right now the government pays 99.999 million of that $100 million. And so we say to the Sierra Club, or one of the biggest environmental groups, has a huge budget, the World Wildlife Fund. They got more money than they know what to do with. It's obvious because of the way they waste it. Say, hey, why don't you contribute to basic or applied research in climate change? You have an interest in it. You're always talking about it. And they say, okay, we'll contribute 10 million. And so then the government's share goes down to 90 million. Okay, and then, the Koch brothers, they did 10, we're gonna do 10. So now you got the Koch brothers and the World Wildlife Fund, and they got putting now 20 million in, and you got 80 million left from the government. You know what you get? You see, you're saying that funding biases research, okay? That's what you're saying, okay? Let's agree with you. So let's broaden the base of science. Let's broaden the base of bias that funds science. Let's diversify sin, because you're not going to get rid of it. Okay? What do you think?
Yeah.
People don't like that.
I don't have I disagree with my provost about, he pays my salary, okay? It's a 6-figure salary, it's a pretty big salary. I don't feel compelled to do what he wants me to do or say what, because I have my own convictions. So the color of money does not really influence somebody's, you know, if I'm a sort of a green valued scientist and all of a sudden oil company money comes my way, I'm not going to immediately become some show for the oil company. You know, it just doesn't work that way. So I don't see it as a big problem, and there's so little industry funding for anything related to climate that I think it's a non-issue.
We have one more question, I think.
Yeah, hi. I actually agree with some of the sort of worries about the current state of publication incentives and that sort of realm. But I wanted to talk about sort of the role of peer review in this process and how you both feel about that, given that you are sort of considered to be in the minority. And I'm also curious if, if I wanted to read sort of your own publications, where would I find that?
Well, peer review has become pal review. A lot of the journals even require that you recommend 3 people to review your papers, okay? You know, and that is pal review at its worst. At its best are the open access journals, online discussion journals where all the reviews are made public and outside people can come in to discuss. That's a much better model, and I hope that we're going more to an online discussion journal format, which I think is a better way to go. But peer review is there's a lot of gatekeeping among communities, but now with the plethora of open access journals, I feel like it's opening up, and people are just publishing on blogs, and it's really opening up. If you want to, my blog is judithcurry.com. If you go to the About page, you'll be able to link to everything,
Okay.
you know,
Does it
related
have
to
your
me, with my
publications?
publications, both blogs and journals, and even books.
First of all, there are very interesting things going on in peer review. I had a paper in Nature in May, and they have been throwing everything back at me since they published my takedown of Ben Sander in 1997. They've been sending everything back to me immediately. Some of these papers are pretty good. And you know why it got published? Because Nature started an experiment in double-blind peer review, where you don't know who the author is, and they don't know who the reviewer is. The thing got published in a month. That was no accident. Number 2, I'd like to play a little game, if I could. It'll only take a couple of minutes. The guy in the blue shirt who asked such a wonderful question early on is now the administrator of NASA. And I'm a senator from Tennessee, and this hearing pretty much actually happened. Mr. Administrator, I've heard that global warming is the most important problem confronting mankind. Can your agency use another $1 billion a year to study it? Is it that important? What do you say? Yes, trust me, because here are all your equivalent vice presidents in the row in back of you, you know, and in their pocket, this is a Washington hearing, in their pocket they don't have combs, and if you said no, that they don't have combs, they have knives, that would be through your back in a minute. It would be the end of you. And so you go to them, say, I got $1 million, guys, what do you think? That's great. Now they go to all their worker bee scientists and say, send me proposals. Which scientist is going to send a proposal that says this isn't a problem? And the programmatic support that these guys ask for is not going to say this isn't a problem. They get the research funded. You submit the paper. Who reviews it? Him. Because you're all publishing in the same field. And your paper says the world's going to come to an end except without revision. You were crazy enough to send in a manuscript that says the world's not going to come to an end. And she reviews that and says, well, I don't want to fly in coach. Let me see if I can find something wrong with this. I'm sorry, we're human beings. You know? It's more wonderful than not being one. Thanks.
You want to follow up very quickly?
Yeah, I have one more question actually for both speakers. Could you both, could you summarize your main points and also the logic supporting your main points without any anecdotes or stories or anything? I was just a little confused during some of it. So.
Okay, climate change is a very wicked problem. It's a very challenging problem. There's lots of uncertainty. Okay, we don't know if humans have dominated the cause for the recent warming. We don't know. We don't know how much it's going to warm in the 21st century. Okay, so what are we supposed to do? Well, I proposed some strategies for decision-making under deep uncertainty and how we can try to cross the value conflict divide. So there are some strategies for decision-making under deep uncertainty, with resilience and anti-fragility and things like that. Those are my main points.
Thank you.
I would like to point out that it's warmer than it was 100 years ago. There appears to be a greenhouse component to the second warming of the 20th century because it's accompanied by stratospheric cooling. Oddly enough, the warming stopped about 17, I guess we're in our 18th year now if you use the monthly record of East Anglia, and in our 20th year if you use the RSS satellite record. That means probably, as a working hypothesis, and scientists should never say, it means this is true. No, nothing is true. Everything is a hypothesis that can continue to be entertained or must be modified. I'd say the working hypothesis is that the sensitivity of temperature was overestimated, and therefore the issue does not have nearly the urgency that it would be if we had those big, fat, high probability tails. Now, how did we get to this situation where the community still will not admit to this? Probably has to do with the incentive structure of science. And so what I am leaning toward is trying to, first of all, explain that there are systematic problems that are not affecting just climate science, but science in general, and that there may be things that we can do about them. I didn't have the time to go in. 2 10-minute segments. Don't have the time to go in. It's a fixable problem, but I fear that the way it's going to get fixed is after there's a very big explosion when the 3 magic words we don't know finally come out.
Have you tried offering sort of competing models or looking into that?
Well, the competing model is a model of the way science works. But there are a number of proposals.
I meant relating to climate change, actually.
I used to be a modeler. I gave that up and switched to booze.
Thank you.
Okay, one more question, and I think then we will close.
Cool, thanks. Hey, how's it going? So I'm going to ask a hypothetical question with 2 small parts. So first is, if climate change will be as bad as some people say it will be, first, how do you think it will affect you 2 personally? Like in your place of residence, how it will affect you personally? And the second part is, if you guys were to move from your place of residence or were to live in an island nation like the Maldives that might face like evacuation in the next couple of decades because of sea level rise, would you be as skeptical as you are now?
Okay. First, I'll be dead by the time any serious effects from climate change are felt, even with the IPCC projections. It's really not seen until the latter half of the 21st century. With regards to sea level rise, the coral atolls tend to rise with sea level. So the fact that they're seeing sea level rise has more to do with groundwater depletion and land use than it has to do with actual sea level rise. If you look at most locations where sea level rise is a serious problem, let's use Bangladesh, that's the poster child. Sea level rise is rising very fast, but only about 15% of it can be explained by global warming. The rest of it has to do with geological processes, groundwater withdrawal, and other land use processes. So when you look at location by location with sea level rise, there are very few locations where sea level rise is a big concern, and the sea level rise itself is dominated by global warming. Usually it's dominated by something else. So none of these things are very simple. Even under the scariest scenarios, we don't really see that much happening until the latter half of the 21st century.
I think you're asking me, what would happen if I moved to Tuvalu? That's where Kiribati is, and the claims for climate refugee status.
Yeah, would you be skeptical?
Well, I would consult the records of sea level of ocean temperature and sea level rise that we actually have about 50 good years of record thanks to the Cold War. And what you would see would be, for the latter 20th century, in a very odd anomaly, the sea level around Tuvalu actually fell. The reason they experienced a relative sea level rise is they pumped all the sand off their beach and turned it into concrete. Not a good idea. Then the incursions of water from a normal wave action get into Kiribati. Now, I read that from the CIA, okay, so it must be right. The CIA report on Tuvalu. But the other thing I would do is I would hope that wherever I move to was affluent. Because if you really, really, really want to do something about climate change, you can't install the numbers. You can reduce U.S. emissions to zero, you're not going to see it. But if you're affluent, it doesn't matter. A hurricane hits Bangladesh, 320,000 people die in the cyclone in 1970. Same cyclone hit basically about 5-10 years ago. This is not good, but 2,300 people versus 230,000. It's because they got even slightly affluent. Here, Hurricane Katrina rips up the worst, most ill-placed city on the planet with regard to hurricanes. A city that is actually below sea level. Hurricane Katrina rips it up, just pretty much destroys it. And try and find the blip on the U.S. economy compared to what happened if it would have hit in Bangladesh. So affluence breeds adaptation. If you really care about these people, you want to help them develop their economies, because you sure as heck aren't going to stop the CO2. Unless there are technological changes, by the way, which there probably will be. So, 10 years ago, you and I would have been in complete agreement that we're running out of natural gas. Instead, between 10 years and now, the U.S. emissions of carbon dioxide went down more than any industrialized nation, because it turns out that those rocks underneath our feet were loaded with natural gas. We reduced our greenhouse emissions more than under any treaty because of economic development, not because we wanted to.
I would like to actually close by thanking both of our principals, and thank you all for coming this evening.